All right, so the last 2 days we've been spending a lot of time talking about how the atoms are structured, how basic bonds take place. We've been talking about how to use the periodic table to then find information about those bonds. So today is just a logical progression. We're moving to more specifics about how atoms actually bond together. So when we look at this, there's basically two types of bonds, and that's ionic bonding and covalent bonding. But I think it might be worth our time to take a little bit more time and just review again the difference between an ion and an isotope. Again, why would I care if you know the difference between an ion and an isotope? You guys remember that from Friday? Why is it important to know that? Where would you see that type of question? Probably on the test. Alright, so what's the difference between an ion and an isotope?
Ions have the same element but different number of
Alright, so it's when we have a loss or gain of electrons. An isotope is similar to that. But instead of a loss or gain of electrons, what is it?
Loss or gain of neutrons.
Loss or gain of neutrons. Loss or gain of electrons and loss and gain of neutrons. Again, that's the big difference between those.
Can you explain that?
All right, so we'll talk to you about electrons again. That outer shell. What do we call those electrons that are involved in the outer shell?
Valence.
Valence electrons. Okay, why are those important? Yeah, it shows you what they can bond with. All right, so let's do this again. I want you guys to draw me a model of a sodium ion and a chlorine ion. So I want you guys to take out your periodic table. I actually want you guys to build the models of these again. A sodium ion and a chlorine ion. Sodium, what is the atomic number of sodium? 11. So I'm going to put on 11 electrons. So 1, 2, and on the next shell I should have a total of 8, which will give me 10. And then I have my 11th electron all here, all by itself. Then if we go to chlorine, chlorine has an atomic number of what?
17.
17. So now chlorine will end up having an open slot. So now what's going to happen is the sodium, in an effort to get to equilibrium, in an effort to have that full outer shell, it's willing to lose that one extra electron. And the chlorine, in an effort to fill its outer shell, will readily take that electron, and we now have a bonding taking place. And that's really what bonds really are. And this is how they kind of find each other. It's all about static charge, and it's all about math. So for those guys that are interested in taking chemistry, it's a lot of math. It's a lot of balancing equations. So it's just a lot of numeric stuff, a lot of moving things around. That's all about understanding how the elements work within one another. So we keep moving forward with this. Here's a little cartoon I found. Well, let's put it this way. Let's go back to here. This way maybe you guys will understand this a little better. Sodium starts off with 11 protons, which means it has a positive 11 charge, right?
Right.
Okay? And then after it gets rid of that electron, how many electrons does it have now?
10
Yeah.
10, so therefore it has a
plus 1 charge.
positive charge. When we look at chlorine, chlorine starts off with 17 protons. And then when it takes on that electron from sodium, chlorine then has negative 18 electrons, therefore has a charge of negative 1. So when sodium loses that electron, it becomes positive. It has a positive charge. So here we go. And so much for the humor.
Wait.
So when sodium loses an electron, it becomes positive.
But when you said correction after the kind of.
That's hilarious, Howard.
Now, when we think about ions, these are the things that are kind of important for our science, especially when we start talking about the types of minerals. And so these are kind of important for you guys to recognize in their formats. SiO4 is called silicate. It makes up over 85% of all the minerals on Earth. So very, very common. Pure silicate is just quartz. In fact, if you look at beach sand, it's pretty much all it is. It's silica. And we're going to keep talking lots and lots and lots about silica all the way throughout this course. The next one is carbonates. That's CO3. We've already talked about one calcium carbonate. That was
CaCO.
calcium carbonate, which is what type of rock?
Limestone.
Limestone, right? Dead sea creatures.
Yeah.
And then finally we have oxides. And oxide is basically any metal mixed with oxygen. So aluminum oxide. And we get to have ferrous oxide. Fe2O3, ferrous oxide. Ferrous oxide is basically the same thing as rust. And ferrous is basically what mineral or what element?
Iron.
Iron. Okay, so that's why iron has the chemical symbol Fe for ferrous. So these are some common ions that we're going to see a lot in earth science, and they do have charges. I'm not going to quite go into that yet. These are some things you guys will see quite a bit in this class. But what I really want to get into today is talking about the difference between an ionic bond and a covalent bond. And pretty much for ionic, it's anytime we have the electron being transferred, it's being given away. So take this sodium and chlorine. That outer electron of sodium was given to chlorine, it was just given away. That's a transfer of that electron from the outer orbital of sodium to the outer orbital of chlorine. It's literally giving it away, it's being transferred. And those types of bonds typically take place between metals and nonmetals. That's the easiest way to identify an ionic bond versus covalent bond. Now, covalent bonds, on the other hand, we're still dealing with electrons. It's all about the electrons for bonding. We're still dealing with electrons, but the difference is, major difference between an ionic and a covalent is that a covalent, the electron is shared. The shared electron. So neither one's going to give it up, they're just going to share it together. And these types of bonds take place between two nonmetals. So two examples, pretty easily, we have water, H2O. What's that other one? C6H12O6. Kind of an important one to remember. Most of you guys need this to live.
C6. H12.
No, not oxygen.
Oh.
C6H12O6. It's not carbonated water.
Dang, I know what it is, but I can't remember.
You seriously don't know what C6H12O6 is?
It's been a while.
Closer. It's sugar, blood sugar. Yeah. Glucose. Almost got it.
There we go.
That's sugar. So the types of bonds that between all those atoms that make up sugar is basically covalent bonds. Alright, so we got this. Ionic bonds, the electron is being transferred, metal and non-metal. Covalent, we're sharing the electron, it's between two non-metals.